Now that was fun, wasn't it? All right. Now, let's talk about some more scientific words. There's a word called a thermocline. Thermo means heat, and cline means change. So it's a change in temperature. So the zone of rapid change from warm water to cold water with increasing depth in the ocean. Now, write that down, but I think the graph's going to help you to illustrate that the best. So if we look at a graph here of temperature and the depth of the ocean, you'll notice, first of all, let me kind of explain this graph. Here's the depth of the ocean in meters as you go down, so deep water right here. And then each of these different graphs, this one right here, is for, what's that one? For the equator. So this is water at the equator right here. This next line here is the water at the tropics, and this is water at high latitude, meaning like up towards the North Pole or whatever. And so what you've got is you have the temperature here. So it's like 25 degrees Celsius at the equator at the surface. And as you go deeper, it gets colder, okay? And then it gets really colder. See, I'm following this down here. And then eventually it meets right down here, and it stays the same temperature. The same temperature at the depths of the ocean. Interesting, it doesn't matter if you're at high latitude, if you're at the tropics, or at the equator. When you get below, it looks like about 2,500 meters, the temperature of the water remains constant. Okay? This is called the thermocline, where there's this huge change in the temperature. See how the temperature changes here? See how the temperature changes here? So it doesn't really, well, it changes big time here. The temperature just gets cold. It actually doesn't change at all. So, but particularly for your tropics and your equator, you get a very significant change in temperature, hence the term thermocline. All right. There's also a pycnocline. All right. That's a layer of water in the ocean characterized by a rapid change in the density with depth. Now we're talking about the density of the water. Remember, density is mass divided by volume. Well, what causes the density of water to change? Well, it turns out what causes the density of water to change is the amount of salt content. So density is related to salt content. All right, so same thing. We go from 0 down to 4,000 feet, and then the density changes. At the equator, we have the least dense water. There's not as much salt. The equator is not as salty. And at the high latitude, it is the saltiest, which makes it more dense. So it actually has to do also with what's called the salinity. And this is called, it follows the same pattern. It's kind of reversed if you think about it. But it's the same concept, is that we have the least dense water, and then boom, there's this huge change as you go down and down and down. And the density changes. Not only does the temperature change like the last graph, but so does the salinity, which is also measured by that density, the pycnocline. All right? That then leads to what's called the circulation of the ocean. So why do I care about the temperature, and why do I care about the density? Because that's what actually causes some of the circulation of the oceans. There's actually sort of three things, and we're only going to talk about one of them now today. The circulation of oceans. There are actually rivers of water flowing in the oceans. These are called ocean currents. So here's a map of the world with some of the major currents of the world. Here we have the Canary Current right here. It's blue. By the way, the blue currents down here are cold currents, and the red currents are warm currents. So the red ones are warm. So actually an interesting thing you might talk about is, for example, if you were to look right here, that's, what is that little town or country? That's Ireland. Ireland, you would think, if you were to go across right here, this is very, from, up where we live, this should be a very, very cold place. England as well. It should be very, very cold, but it's not. That's because you see there's this warm current that comes across here and warms this whole area up here. So you've got a warm current which keeps the climate of the region warm. And we've got the Brazilian current here, which is a red one, so that would be a hot current. Okay, the Gulf Stream, okay, that's a pretty warm current, etc. The Eastern Australian current, we have a little clip on that one. In fact, that's a warm current down in the southern hemisphere. So there's actually two types of currents. One is called a surface current, and that's what we're talking about right now. All those currents on that map on the previous page were surface currents. And there's also something called deep water currents, which is the topic of the second podcast. So we'll get there in a minute. So let's watch a short clip about the East Australian current. You might recognize this. It's kind of a fun video clip.
Oh, my stomach.
Oh, man. Hey, no hurling on the shell, dude, okay? Just waxed it.
So, Mr. Turtle.
Whoa, dude. Mr. Turtle is my father. Name's Crush.
Crush? Really? Okay, Crush. Listen, I need to get to the East Australian Current. EAC.
You're riding it, dude! Check it out! Okay, grab shell, dude!
Grab what?
So, what brings you on this fine day to the EAC?
Well, Dory and I need to get to Sydney. Dory, is she all right?
Ah, a little blue. She is sub-level, dude.
Dory! Oh, Dory. I'm so sorry. This is all my fault. It's my fault.
29:30. Ready or not? Here I come. There you are. Let's dig again.
Oh my goodness!
Whoa, kill the motor, dude. Let us see what Squirt does flying solo.
Whoa! That was so cool! Hey, Dad, did you see that? Did you see me? Did you see what I did?
You so totally rock, Squirt! So give me some fin. Noggin. Dude.
He's in